like to now pass the mic to the moderator of the next session, with my apologies for the delay. Dimitris Mandalozis is the Chief Operation Officer at the Aegean Motorway. Dimitris, your microphone and video on, and then we'll...
Good morning, Susanna. Good afternoon or good evening to everybody, because we have so many people from different parts of the world. I would like to proceed immediately as we are running out of time. So today we're discussing about IRF innovation updates, and I would like to introduce our panelists or presenters. First of all, Valerio Molinari, who is from company Ecogest, which is his position is from the company's majority shareholders. Emma MacLennan from the Eastern Alliance for Safety and Sustainable Transport, which is director. And the third one is our Ziya ÇAKICI, I hope to pronounce it well. He's a assistant professor from the Izmir Democracy University and Turkish Road Association. So I will pass immediately the floor to Valerio. Valerio, you have 5 minutes, and then we go to the next presenter.
Good morning everybody, or good afternoon. My name is Valerio Molinari, and I'm the majority shareholder of Ecogest company. Thanks to IRF, thanks to Susanna, thanks Bill for this invitation to speak at this here annual conference. Starting from the 50 years experience of Ecogest, the leader company in the sector of maintenance of roadside vegetation along roads and motorways in Italy, and promoted by its holding company, Greenway Group, the Climate Change Study Center was established in November 2020. The CCSC promoter committee stems from the collaboration between Greenway Group, the founders of the KASSANDRA project, and some of the leading Italian experts in EASST and in EASST Servizi, in order to monitor the impacts of climate change on transport infrastructure. The purpose of CCSC is to provide useful information regarding resilience, is to promote the exchange of good practice between operators and end user, and to propose related project initiatives and research and development activity. The starting point is the scientific facts. Over the past 115 years, the global average temperature has risen by nearly 0.8 degrees and by around 1 degrees in Europe. Without concrete action to limit future emission, the global temperatures are expected to further increase by 2100. Several effects of climate change have already been observed on soil and vegetation, such as anticipation of flowering periods, lengthening of the growing season, changes in natural cycles of plants, and uncontrolled spread of invasive alien species. These effects produce and will produce in the future a great impact on the state of health of infrastructure networks. A new approach is fundamental so that the infrastructure can be protected and every maintenance logic can be in step with the times, with the renewed needs, and with the consequences of climate change. The CCSC began its journey in Italy with a proposal to Italian concession for the development of projects and research activities related to the resilience of motorway infrastructures to climate change. The first project is a pilot study consisting of an analysis of 3 sections of a motorway operated by CAV, Concessioni Autostradali Venete, in northeast part of Italy. Throughout the Cassandra innovative methods, this study analyzed the state of the sites and identifies a resilience index based on the Cassandra study parameters, proposing different scenarios to identify an optimal solution based on the resilience index achieved. The study is intended as demonstrative of the functionalities of Cassandra, and now by acting on the parameters, the infrastructure's resilience index of the analyzed section can be improved. KASSANDRA is an integrated decision support system that facilitates the creation, development, and management of the resilience and sustainable cities and infrastructures, with a control over all phases from design and execution up to maintenance and management. The application of KASSANDRA along the motorway operated by CAV SPA will first allow to point out current critical issue in terms of resilience to climate change and impact on the quality of life of users or those who live in the vicinity of the motorway. By creating a digital twin of the selected section, KASSANDRA will allow the modulation of different scenarios to improve the critical issue found in the current state, such as noise pollution, improvement in air quality, biodiversity, water management, or visual pollution. A database of parameters will allow to represent real quantitative and quantitative data, quantifiable and scalable to larger sections of the motorway, with the final goals of giving an overall view of the resilience to climate change index of the entire motorway operated by CAV. The main objective of the study is to identify potential critical issues arising from or caused by structural, vegetational, morphological, hydraulic, or landscape elements currently present along the analyzed motorway by monitoring, analyzing, and assessing a series of parameters throughout the application of KASSANDRA. The study will allow to hypothesize a series of eco-sustainable environmental mitigation and compensation measures that at a later stage can be included into detailed design. It will also make it possible to identify the best intervention to be adopted in order to optimize both technical and economically that infrastructure and green areas maintenance and management plans, thus increasing the period of full efficiency of each infrastructure. Thank you very much.
Thank you very much, Valerio. So, from what I understand, because this is a very interesting presentation, we see that there is a connection between the climate change and the general condition of transport infrastructure. But I have a question for you more specifically about KASSANDRA. So why is KASSANDRA so unique?
Dimitri, yes, thanks for the questions. KASSANDRA is the only multidisciplinary and fully comprehensive IDSS that reach high levels of geographical accuracy. It is the only IDSS directly linked to asset quality of life indexes, and is the only system that allows for the prioritization of economics in areas where they will have a great impact on resilience. And it is the only SS capable of measuring and visualizing positive action by an individual at the same time of an entire community.
Okay, thank you very much, Valerio. So we are going to our next speaker. Good morning, Emma. So we have with us Emma MacLennan. So Emma, the floor is yours.
Yes, please. I need to share my screen. So if you could.
Okay.
Okay. Thank you very much. Thank you, everyone. I'm Emma MacLennan. I'm the Director General of EASST, the Eastern Alliance for Safe and Sustainable Transport. We're an NGO. We're actually a network of organizations working across 15 countries in Eastern Europe and Central Asia. I'm also the Deputy Chair of FireAid, which is a charity I helped to establish, which gives direct support to low and middle income countries with improving post-crash care and response. So why is this an important issue? Because we know that the Decade of Action, the new global plan for the next decade, is calling for a reduction in traffic deaths and injuries by at least 50% during that period. Part of the global plan includes post-crash response as an important feature, one of the key pillars. And the World Bank and other researchers have estimated that something like 30% of all injury deaths could be saved in developing countries through better trauma care. So this is a great opportunity for achieving those global goals, which we're all committed to. So with that in mind, the World Bank Global Road Safety Facility supported, and the European Bank for Reconstruction Development initiated a project by FireAid and the George Institute for Global Health and EASST to do a capacity review in 4 countries on specifically related to post-crash response. And those are Tajikistan, Kyrgyzstan, Lebanon, and Egypt. And in all those countries, we looked in detail, working with local partners and all of the rescue services into issues about their equipment, their training, their coordination. And we found very similar problems. There were problems with organization, with location data, with planning. The equipment base was extremely poor. And based upon this, we've produced for the European Bank for Reconstruction and Development a post-crash emergency response toolkit, which is available in English, Russian, Tajik, Kyrgyz, and Arabic. And we'd be happy to discuss this with any of the attendees here. In addition to that, we've produced 6 training videos which capture some of the most important key things that we need to do to get post-crash response right. For example, intervention at the scene, how you organize that, coordination and data, equipment and training. All of these things are very important. I'm happy to share links on the chat line, which I'll do after this presentation. Finally, as part of the project, we commissioned an analysis by Agilicis, who are very brainy people, who calculated the cost-benefit ratios of investing in primary emergency care as set out by the World Health Organization in the 4 countries. And I should add that when you invest in good post-crash care, you get added benefits in people in emergency services responding to other important emergencies, such as heart attacks and other crises. So the most dramatic response we found was that with the investment required in Lebanon, you would have a ratio of 57.5 times every dollar that was spent in investing in post-crash care. But in all countries, I should say these are low, very conservative estimates. We all used conservative figures. So the post-crash, investing in good post-crash training, equipment, organization, and care is not only incredibly important for saving lives, it also is a good investment and saves money. And on that, I'll end it. And as I said, I'll put in links to the resources that I've mentioned in the chat, but my email is here. If anybody would like to get in touch, I'd be happy to contact.
Thank you, Emma. Thank you, Emma. Thank you very much. And I would like to apologize to you and to the rest of our attendees because we don't have time for questions. So I would like to immediately pass the floor to our next presenter, who is Mr. Ziya ÇAKICI. I hope to pronounce it well. Ziya, the floor is yours. And
yes, I can hear you, but can you hear me?
Yes, I can hear you. So
yes,
okay. So
I need to share my screen, please. Yes. Before my presentation, I should point out that this study is a part of my PhD thesis, supervised Professor Yetisazi Murat. Thank you, dear Dimitris. You can see my presentation outline on this slide. My presentation consists of 5 parts. I referred these part by part. Economical and technological developments all over the world bring about increase in the number of vehicles. With this increase, the most of road networks has been inadequate day by day. Many decision makers think that this problem can be solved by building more new road networks, but this is not an appropriate and reasonable solution. Instead of building more new road networks, the improvement of existing road networks may be more sustainable and reasonable solution. An effective traffic signal control is one of the most used applications to improve the existing road networks. In the literature, the number of studies considering both signal timing and signal phasing optimization are very few. Therefore, we developed, in the scope of this study, we developed a new signal timing and signal phasing optimization-based traffic management model, SPOTM. In the developed model, signal timings and signal phasings are optimized simultaneously. And in addition to these, both signal timings and signal phasings are updated dynamically at regular intervals. Because the differential evolution is an effective, easy, flexible, and powerful algorithm, we preferred this algorithm in the scope of this study. You can see the basic step of differential evolution algorithm on the figure. Delay is important performance parameter for signalized intersections. It is used for determining the performance and the level of service of signalized intersections. As can be seen from the figure, this parameter consists of deceleration delay, stop delay, and acceleration delay. Webster, HCM, and Akçelik delay models are the most used and well-known delay models, while Webster and HCM aim to phase-based signal design. Akçelik aims to movement-based or lane-based signal design. In this study, lane-based traffic volumes for the signal timing optimization and conflicts of traffic flows for the phase plan optimization are considered as determinant factors. So we used Akçelik delay model in the optimization process. In the scope of the study, we created two different signalized intersection models. One of them, the first of them, has 3 leg and 8 lanes. The second one has 4 leg and 14 lanes. We considered 3 types of intersection management model on the scope of the study. First one, optimum fixed time management, OFTM. The second one, vehicle actuated management, VAM. And the third one, the last, signal timing and signal phasing optimization based traffic management, SPOTM. We applied this intersection management model on both 3-leg and 4-leg signalized intersection models. For OFTM, green signal timings are constrained between 7 seconds and 45 seconds. The degree of saturation volume for each lane is constrained with a maximum of 1.2. For VAM, the order of phases is variable, minimum, maximum green signal timings, arrival headways of traffic flows, and placement of detectors are determined considering previous studies in the literature. For SPOTM, lane-based traffic volumes are used for optimizing the signal timings. Merging, diverging, and crossing movements of traffic flows are considered for optimizing the signal phasing. For 3-leg and 4-leg signalized intersection model, 8 and 21 possible path plans are created respectively. You can see a flowchart of SPOTM. In the scope of our study, firstly, we created 42 traffic volume scenarios which have different total traffic volume from each other for both 3-leg and 4-leg signalized intersection for testing the effectiveness of SPOTM. Then we analyzed each scenario with VSIM simulation software considering OFTM, VAM, and SPOTM separately. At the end of the study, we concluded that for 3-leg intersection model, we determined that average vehicle delay may be reduced by the rates of average of about 45 and 35% with SPOTM comparing to OFTM and VAM. for four-leg signalized intersection model, we concluded that the average vehicle delay may be reduced by the rates of average about 30 and 15% with SPOTM, comparing to OFTM and VAM respectively. I want to finish my presentation. An American urbanalist, Lewis Mumford, said, building more roads to prevent congestion is like a fat man loosening his belt to prevent obesity. Thank you very much for your attention.
Thank you very much, Ziya. Very interesting results. I would like to pass the floor again to Susanna for our next session because we don't have time for questions. So, Susanna.
Yes, thank you very much, Dimitris. And Ziya, if you can stop sharing your screen, so that will allow us to move forward. Thanks to the moderators, thanks to our members who have been presenting some updates from their side. Keep pushing your questions in the question answer function. We will make sure you get answers probably offline. And with